This is our line following robot presentation for Mechatronics ME1301.
I'm Tyler. I'm Anthony.
I'm Matthew. For our overall design, we started with a Plano organization box, which is 3 3/4 inches wide and 6.5 inches long. It's less than $2 to buy. And to drive this car, we use 2 geared motors situated in the back of the car. These are both connected to the large orange wheels, which are provided in the kit. For to support the front end, we used Legos as skis in the front to glide across the paper. The photoresistors and sensors are situated right under here, and this is a hood to keep out any ambient light from getting in and affecting our readings. In the rear of the vehicle, we have a servo to drop a black rectangular piece of cardboard for our marking mechanism.
To explain our line following algorithm, essentially what it is a set of if statements. So in the if statements, we took photoresistor readings of the photoresistors on a white spot on a piece of paper and then on a black spot on a piece of paper. And from those readings, we were able to determine a middle point where it would separate the two values. So that one value that we got that was in between both a black sensor value and a white sensor value is what we then implemented into our if statements to then control where the robot goes. So in the if statements, we have if one photoresistor reading reads white and one reads black, for instance, what it will do is it'll turn it a certain direction, and if they're both white, it'll go straight, and so on. So what the car is doing and how, as I mentioned before, it is using a set of LEDs and photoresistors, and the LEDs are shining light onto the paper, and then the photoresistors are then reading the light from the LEDs that is bouncing off of the paper. So then from these readings, as I mentioned before, we were able to get a value and then use that value in the if statements to be able to tell the robot when it needs to turn or when it needs to go straight or when it needs to stop. So how the car stays on track and how it turns is, as I mentioned before, we have the photoresistor readings in the if statements. So for instance, to tell the car to turn right, in the if statement we have the right photoresistor will read black and the left photoresistor will read white. What that means is that then the robot needs to turn right. So what it does is then it provides power to the left wheel and then decreases power to the right wheel. Then that will turn the robot. And then if we want it to go straight, we have the if statements say that if both photoresistors read white, then it will go straight, meaning both the motors will rotate at the same speed. And then if we want it to turn left, the left photoresistor will read black and the right photoresistor will read white. Then that way it will tell the right wheel to increase speed and left wheel to decrease speed. And then if we want it to stop, it will pick up each reading from the photoresistors will be black, and then it transmits no power to both the wheels.
For the start and ending position marker, we use a black piece of cardboard, as I stated earlier. This black piece of cardboard is attached to the rear of the vehicle, being sandwiched in between the arm of the servo and the chassis of the car. And once the car finds the line and situates itself on the line, the servo will open up, allowing the piece of cardboard to drop down in the center of the track for the car to find while it makes one full loop around the track and then know when to stop where it started. After it stops where it started, then the car will display its total distance of the track at the LCD display.